How's everyone doing today? Everybody get some lunch? Belly's nice and full? This isn't beer. It's Club Mott. It's the Malort of Berlin. I want to start off today with a question. How many people in the audience have ever set up a yarn cluster? A couple. All right, pretty good. How many people have set up a real yarn cluster? And what I mean by that, not one on your notebook, just to see if you could do it. A couple less, it's okay. Final question. How many people, if your boss or whoever that may be, called you right now and said, look, you better have a yarn cluster set up for me by the time you get back from Berlin, or don't bother coming back? How many people would that cause some stress or angst? You're liars. Oh, yeah, thank you. I work for IBM, and I promise this isn't going to be a pitch, but I want to show that the world we live in now, this is our, online, this is Big Insights on Bluemix. It's a cloud cluster. I said how many nodes I want, select services, hit create. 10 minutes from now, I'm gonna have a yarn cluster, a 6-node yarn cluster in the cloud that I can run against. And the important point there is that technology has come to a point, whether we realize it or not, that a 6th grader could set up a yarn cluster with relative ease if they know where to look and what tools to use, budgets, et cetera, et cetera. And it is my opinion that if a 6th grader can set up, nope, not what I wanted. If a 6th grader can set up a yarn cluster, then a 6th grader should be able to install Flink and start playing with it and copying and pasting demos. And that means not necessarily being able to set up an IDE and compile Maven jars. And things that weren't as easy is saying 6 nodes, username, password, create. That's the level of difficulty that I feel like most of this stuff should be at. But first I'm going to tell you a little bit about me, give the obligatory intro. Founder of the Chicago Apache Flink meetup, committer on the Apache Mahout project, contributed a little bit to FlinkML, a little bit to Apache Zeppelin, and I am a former data scientist turned open source technical evangelist at IBM. So that's my background. I first learned about Apache Zeppelin at Flink Forward last year when I realized, we have, you're familiar with Databricks and their cloud infrastructure, very, very similar. But we had some data behind a private wall that we wanted to work on, and it seemed like a really, really good fit for our R&D department. So that was how I first got involved with Zeppelin. Thought it was an amazing tool for reasons I'll go through now. But the main thesis of this talk is going to be that big data should be accessible to everyone. We've got this paradigm where this idea of there's data scientists and there's data engineers, and you've got to have them work together because only the data engineers really understand the distributed nature of everything, and the data scientists are the ones who understand the mathematics. And that's always really bugged me because when I started calling myself a data scientist, you were both in the same. But more so, it bugs me because the concept of big data, it belongs to everyone. Anybody should be able to pick up and do some streaming k-means or whatever algorithm you want to try out just as easily as you fire up Excel and take an average and a standard deviation of a big column. Anyone can do that. Yeah, computers are kind of complicated and it takes a little bit to get that, but it's still pretty base level things. And a lot of that's because pretty UI tools have developed. So this presentation, by definition of the people who are in this room, probably isn't for you. I'm not going to show any cool new features of anything. In fact, I'm showing only the most basic features of Zeppelin and the most basic features of Flink. What this is for is when you go back and you want to give those presentations and meetups, and you want to, or you're trying to sell in Flink either internally or externally, and you want it to come across as something that's not scary, that really simple. here's something, we can set you up, and you can be playing with Flink in 5 minutes, doing copy and paste, word counts, simple examples. So, what is Apache Zeppelin? If you haven't figured out by now, you're looking at it. It's a web-based environment. Of course. All right, it didn't crash. Okay. It's a web-based environment for, as I was just saying, it's the IPython and Jupyter of big data products, with an added benefit that you have multiple languages in a similar notebook. A lot of other really cool features too, and I'm sure when the guys who run the Zeppelin project see this and get a hold of me, they're gonna wring my neck for not really talking up the new high-end features. But high level, that's what it is. Multiple languages also allows us, because of the multiple languages, cool tricks where you can start leveraging the graphics libraries of other languages to visualize data you've done in something else. For example, FlinkML, visualize in R with ggplot. We'll get into that later. The big important thing, though, that I want to point, how hard is it to get set up? Not. 3 lines at the shell. Most are probably pretty familiar with what this does, so I won't have to go through it. You download, untar it, start the daemon, log into a web interface that's going to look exactly like this. You start a paragraph with the %Flink to let it know that, hey, this is for a Flink, and you're running Flink. You're running word counts. That's it. That is about as 0 to 60 quick as I can think of to get someone started playing with Flink. When you do it this method, and the reason you don't have to install the full Flink cluster and everything is because Zeppelin ships with a mini cluster. The mini clusters use a lot in testing if you're in some other things in local mode. It's a tiny little cluster, won't do a lot other than let you run simple examples, but that's okay. Now the question is, okay, that's fine, but what if I want to start doing some more serious things? Is this just a cute toy, or does this have some real power? The answer is yes. It will support clusters. It won't support Yarn yet. That is a problem on the Zeppelin side that I didn't realize was even a problem until I tried to do it here. And I'll hopefully we'll be correcting soon, I would hope. Now, I started this off, I kind of jumped ahead of myself with this big punchline that we can set a cluster up and, just a couple things in a web GUI. Once you do that, I don't want to do any magic hand waving and mislead you into thinking things are a little bit easier than they actually are. From that point, if you're trying to follow along at home, a little bit of Python, a simple API. I'm not going to go through the code, but the gist of it being install, upload some configs, start the cluster, and you're running Flink on a major cluster. And to prove that that's what's going on here and I've got no tricks up my sleeve, this is the cluster that we're running on. I have task managers. A lot of power at my disposal that I'm not using. And you can see I've got some jobs running. We've got a Twitter example going on later. It's collecting data right now. So just to wrap up this part, big data should be easy to get into and try out. And that's what I'm going to hopefully convince you of today, that using Zeppelin makes a lot of things that would be scary and complex to a newcomer, like simply getting into a command line interface, simple and friendly and easy to use. So I said you'd be up and running on simple examples in no time. This is simple examples. The classic word count example. I'm guessing everyone's probably ran this at some point or thought it was so trivial they didn't bother. Okay. This is done in the batch environment. Since streaming is the thing that we're all excited about this year, we just added the streaming, we just updated Zeppelin to run on Flink 1.12 and now have streaming support. So when when you set up your Flink paragraph, the environment is already declared for you. And the way this is done is just like in the Scala shell. If you're not familiar, you have b-env is your batch environment, and you have s-env, your streaming environment. Declare some words, you do your count, execute, or just do a collect. And that is it. Now you could say, compared to the Scala shell, that this isn't a significant improvement. And that's fair. And we're going to explore really quickly. You're going to see the divergence in things you can do in Zeppelin versus things you can do in the Scala shell. First thing is going to be loading jars. This was originally written to be an hour presentation. I didn't read the right instructions, so I'm going to skim through this really quick. When we load jars in Zeppelin, instead of doing class path, go set your interpreter, edit, and add. You can do a Maven artifact, or you can send a path straight to the jar. That uploads the jar, and you've got it. Similar so no error before, we load the jar, or error before, load a jar, no error. That's something, I don't know, you might think loading class paths are an easy thing to do. When I was starting out, it gave me a lot of headache trying to figure out why my imports weren't working. I came from Python, data science. So bringing me to my next thing, the data scientist. And we've been talking a little bit more about ML. ML's coming back into the idea of things we're interested in with Flink. That is something we want to do. Before data scientists are actually going to work with an environment with like Flink, that interactive shell is a must. You want to be able to run a little result, check it, try something else. Compiling your entire algorithm into a jar and then submitting it, it's just not the nature of the way we do things. We also want to have access to plotting and a really nice library of functionality that we can fall back on. This is the simple ML example. Again, something you all probably, if anybody's done any ML or Flink ML, this is copied straight. All the demos I have here, copied straight from the docs and websites, and I try my best to provide the links to where I got them from. This is the simple, from the quick start page, we download our data. We also have a shell interpreter. So we just do a little wget, we can pull our data. Also nice about this is when you're working on this, the idea is you can share this notebook and you can say, hey, look at this cool thing I've done. And you can send the entire notebook to your friend and they can see step by step exactly what you did, including when you had to drop down to the shell and do things like get the data and where you got it from and things like that and the last time that you picked it up. So we've collected our data. We do, again, from quickstart.html, we run our basic, turn it into dense vector, labeled vectors. This is, and I don't really want to code people to death, but basic MLR example, and we get our output, the sum of squared residuals, a diagnostic measure for multiple linear regressions. Now, as a data scientist, I might not like that example. And so instead of recompiling my jar, because all I want to change is, let's say, the step size and see how it affects my output, copy and paste, change my step size, my one little parameter, run it again. And I print out my old one and my new one, and I can see my squared residual, which higher is worse, has gone down significantly. And now I can show someone that. Be like, look how better, much better my error metric got. After all I had to do was change one little thing. And it's a much nicer presentation format than, for example, recompiling a jar. Next thing, now, FlinkML is, I think, and most people will agree and have talked about, there was some focus on getting the streaming framework really ironclad. FlinkML doesn't necessarily have a lot of the power that you really would want for doing some serious data science. I'm a Mahout committer, so my shameless plug, enter Apache Mahout. If anybody hasn't heard of Apache Mahout for a while, what we're up to these days, this is the description from the website. But generally speaking, a unified API for doing machine learning with an emphasis on linear algebra to make it very easy to write your own algorithms. And that the same API, that same code can be transferred from Spark to Flink to H2O. We have multiple underlying engines, and we're hoping to add more. Case in point, on the, as you look at it, left, you're going to see Mahout, and right is Spark code. A couple different imports, because we're binding to Spark instead of Flink. Starting from this line on, this is the exact same code, line by line, exact same. And what we're doing here, again, I don't want to go through code line by line. This is from the Mahout website. It's a simple OLS regression. We're doing OLS, but that's least squares that requires doing matrix flops and matrix multiplication to find the output of a linear regression. Small matrix, it's nothing exciting, but Mahout has a very large and rich library of functions you can use for doing data science, and this unlocks it, and it unlocks it on Flink and in that nice REPL environment that a data scientist is going to prefer. But when it's time to actually put this machine learning into production, same code, packaged into a jar, shipped off to a Flink. The other fun thing about Zeppelin is there's this concept called a resource pool. And a resource pool is basically a block of memory that Zeppelin controls that you can write objects into and then pull them out from other interpreters. And in that way, we can share serializable objects between languages. For example, well, I'll get into more of the stuff, but you can send a variable from, like, say, Flink to Spark. And what that becomes in really cool for is in Mahout especially, and this can be done more or less in Flink, but we've got some API for it. In Mahout, we set up our DRM, which is the distributed row matrix. That's our concept, similar to the data set or the RDD. We have our DRM, it's our matrix. We sample it because in theory, it's too big to get the whole thing in memory. We sample however much of it we want, and we convert that into a tab-separated string. Looks just like a tab-separated file. We take that string, we throw it into the resource pool, we go to R, we fish it out of the resource pool, and then we have all of R's plotting capabilities, ggplot2, Google Viz, or anything from the matplotlib from Python at our fingertips to visualize data. And again, this can all be done in line. Now, I didn't have a working demo because I forgot to install R on this box, and I realized that about 3 a.m. this morning. So this is a picture of about what it looks like. And I've got good blog posts, and it's pretty well documented how to do it. So in the section, the big key points that I wanted to hit on, and I hope, again, that maybe I have. As a data scientist, we want an interactive shell where we can try a little something, see what we get for results, and then try a little something different, but also have that inline documentation where we can talk about what we're doing, so when the next person comes through, it's not somebody else trying to understand what kind of insanity we were going through. We want to be able to visualize our output, and we want to have some actual real horsepower and ability to do cool algorithms and cool things. And the tie back with Mahout then being is it really widens everything up. And if you can express it in matrix form, you can translate it into a Mahout algorithm. Now the resource pools. I kind of held myself back on this. I'll get into a little bit more. The resource pool, again, just a pool of memory. We import, this is how we set it up. And from there, we can send strings into the resource pool, and then we can use other interpreters such as Spark to fish them out. We can also, we're not limited to strings, even though those are the last two examples. We can use straight lists. Put a list into the pool, we can use Flink, we pull out the list. Same, and we can use PySpark, and we can use R as well. And so usually the thing that we end up using this for, and the reason it was existed in the first place was to support the visualizations. It originally was really meant to support the Angular visualizations that Zeppelin does. However, there are some interesting and kind of cool things you can do with this. The last talk in here, we were talking about doing streaming and running a batch ML job on the side, firing the predictions back to the streaming algorithm to update itself. Now, he was using HDFS and writing and reading, but it said, you could probably use a Java pool, something. This is a Java pool. All your components are right here. You can run a streaming job in Flink. You can have Flink or Spark or whatever else you want, doing the machine learning offline and then updating your streaming algorithm as you go. In theory, I haven't done it, but it's an exciting demo for someone to give a talk next year on. Now, how many people have worked with Jelly? Couple? Okay, one. Jelly's really cool. I like it. The problem I always had with Jelly is I couldn't visualize anything. And I'm not a graph algorithm person, and so I wanted to look at what I had. There aren't a lot of packages. There are some packages here and there for analyzing graphs. But this talks about Zeppelin, so let's see how we can do it in Zeppelin. We collect graph data. the trick we're going to use here is Zeppelin also has an HTML interpreter, and what we're going to kind of do is we're going to create a new HTML text with our data that we've trimmed down, and the output's going to be, after loading this is a graph of character interactions from Les Mis. And, are there better ways to graph things? Probably. But when you're doing demos like this, people get really excited about fun graphs that you can interact with and drag around. And this isn't a particularly great one, and we haven't done any jelly yet. So let's see how we can get Flink in this. Very simple example. Again, copy and pasted pretty much, except for the JSON part. Straight out of the docs, we collect our JSON and create a graph of the nodes and edges. The JSON itself had nodes and edges present. And the simplest of functions, let's do a filter. Let's do a filter on anything with edge value greater than 2. That's all we're trying to do here because, again, I'm not trying to show you all the power of jelly. I'm trying to show you a cool trick to visualize your graph results in line with your code. So we do a quick filter, and now we've got a much nicer looking graph that makes sense. We see here's these characters that only showed up once in the book, weren't really important. Here's Fontaine, and it's a fun graph. Anybody familiar with D3JS will also kindly point out this is not a beautiful D3JS chart. The exciting punchline of being able to use D3JS is there are some beautiful charts available. And because I was using only the simplest of examples, this is a simple, very simple D3JS chart. But everything you find in the D3JS library is at your fingertips to work with in your demos and your presentations. And really, that's the sort of thing that's the crowd favorite, especially when not working with extremely technical users. Now, the streaming interpreter. It's what everyone's excited about. I guess everybody's really excited about streaming. But when you first want to start playing with streaming and trying some things out, again, having that interpreter REPL environment where you can just check and play things, it's nicer. It's easier, especially for those of us coming from Python. In this case, the simple Twitter example. We are taking, this was the hardest part of the entire demo, was figuring out how to make this endpoint. So if anybody else is trying to do simple Twitter examples, this is how you hit status as filter. I'm basically looking for any tweets that contain FF16 or Flink forward. And I'm going to stream them in, and I'm going to count. I've got a sliding window of 2 minutes that offsets every 30 seconds. And we're going to count how many tweets containing that are in each window. Again, bare bones simple example of streaming to just technically show that you can do it. But I encourage everybody, take what you find here and then start building up and iterating into cooler examples and share them back out. From that, we use, again, AngularJS charts that are built into Zeppelin. And I started recording this at about 3 this morning. But here's it by, by window, which is a somewhat convoluted idea too, as they're sliding windows. I'm syncing my stream to a text file. I read the text file. I visualize it. And again, this is something that we could have done anywhere. You can raise the argument, and you'd be right. I've done nothing here that couldn't be done somewhere else. What I have done, though, I hope shown, is that it's a nice environment that's got everything in one place. And if you're just trying to play and do a little this and do a little that, it's a great place to learn. It's a great way to introduce people and help them get their first steps and take their first steps into the world of Flink. And then, I forgot I had one more. This is also Zeppelin. This is the word count, kind of tying it back to the beginning. Once again, we're going to do our simple word count example, and we chart, I think we're doing how many, keyed by the count, how many words. So most of our words in the word count existed once. One of them existed 7 times, a couple existed 7 times. Again, interactive chart, but makes things a little more exciting than simply, and here's a word count example, and it prints out examples. Makes compelling demos, makes exciting things that will hopefully engage your listeners enough that they want to go play with it. that they want to go try something out, that they see something that sparks their curiosity, and it seems like the sort of thing that they could just pick up and copy and just try extending it just a little bit more. So that's what I hope I've imparted on you today as well. And the other idea is then once they've gotten that familiarity and comfort level, it doesn't take long of working in notebooks before it drives you nuts and you start realizing how great an IDE would be with code completion and all those amazing things that an IDE offers. And again, okay. With all the things that an IDE offers. And creates an environment for data scientists. Most of my work in Zeppelin got done. I was working research and development, doing data science. I wanted to have access to a large number of tools, and I wanted to have them at my fingertips. And this was a great notebook or environment for that. We only hit on Spark in passing and Flink and the shell interpreter. Also have Hive, Postgres, anything with a JDBC connection, Alluxio, Big SQL. The list goes on. Ignite, Angular, BigQuery, Cassandra, Elasticsearch, File. This is for HDFS file systems. Flink. I've got about 20 different Flink interpreters in here because I was doing all these different demos. HBase, Ignite. The website will go on. The idea is it's great for not just Flink and not just working with Spark, but almost any conceivable stack you can have. You've got access to all of those pieces right from one place in one place. Another, and again, there's so many more features on this that I lost my end slide. There we go. And first and foremost, again, great for demos, great for meetups, personal opinion, but obviously I believe in it. All the notebooks that you've seen here, I'm going to commit, they'll be on GitHub. My notebooks can be imported into your local Zeppelin instance, and you can see my code and how I ran it. And there's also the script I actually used to set up this entire environment with all my interpreters and all the jars loaded will also be shared on GitHub, so you can literally create your own Big Insights environment that should run this exactly. You pull in your notebooks, and you're good to go. So with that, I want to, like I said, I just so carefully or so quickly grazed across so many topics. I want to open up for a little bit of a longer of a question and answer time and see what you guys think and answer questions. Looks like we got one in the back. I think there's going to be a microphone that comes up. Sorry,
Hello. Yeah, so my question is about ResourcePools.
Yes.
Let's say I put something using like Scala. Mm-hmm. Can I access it in Markdown or any language that does not? So, for example, a language that does not have variables and stuff, how do I access the ResourcePool from there?
It needs to, I am fairly confident, because I haven't tried to access ResourcePools from Markdown, but I believe it needs to be something Java or Scala based, with the exception of Spark, PySpark, and SparkR, because they have such weird Java integrations anyway. And I guess the way it happens is there's a package in R and a package in Python that allows you to have Java connections, mm-hmm. and that's really what's making that happen in Python and R. So if you can do some sort of Java something anyway in that language, then you can probably work your way into getting to the resource pool. But I think you need to have some sort of Java hookup there at some point.
Okay, so just an extension. Let's say I have a new language like Julia.
Okay.
Then what all do I need to do to access variables, let's say stored using Python, to access them in Julia?
I'm not familiar with Julia. Is it Java-based, like Scala?
I mean, okay, take any other language that's, let's say,
Java. Okay, any new language?
Yeah.
You can always pass things back and forth through a file. That's a good point. That's always a fallback. What I would say, though, as far as like that specifically, let me see if I can find the resource pool. The best hint that I would give you would be to go read this find this code in all these projects are Apache Zeppelin, Apache Mahout, Apache Flink. Find this code and see what they did, and if you can dissect it into doing something similar and to reach the same memory blocks.
Okay, thanks.
Nah.
Nice.
Hi, thanks for the talk. I think Zeppelin's really cool, and it's great to see the Flink aspect just continuing to come into it. Can you elaborate a little bit on how the streaming interpreter works? In terms of like since the job doesn't complete, etc. How does the cell's state work?
Yes, that is a good question. Which I can show if I find my streaming interpreter, which is here. So what will happen is, so let's say we execute, you'll see that this paragraph was aborted. That's the status. What it does when you start a streaming job in a paragraph, that as long as supposing that stream is going to just run and run and run forever, then that paragraph is just going to run and run and run forever. That is where using cool things like the resource pools, or in this case, having to sync to disk, and then read it with another interpreter. So a little bit of the behind the scenes here. If you look, this is done on the Flink Streaming Interpreter demo interpreter, and this is read out on just a regular Flink interpreter. Now, the way you can get your paragraph back if you want it is you go to your interpreters, and the cancel job, it doesn't always, normally you would cancel a job by just clicking this, there'll be like a little pause button up here. It doesn't seem to respect it very well. If you go into your interpreter menu, you can restart the interpreter. However, restarting that interpreter will just, all that does is break Zeppelin's contact with that job. So Zeppelin just kind of stepped back and abandoned it. And if you see then, I had run this 14 hours ago, and now I've aborted the job since then, but the job still runs. So you would have to come into your cluster and kill the job, or just restart, or command line interfaces, et cetera, et cetera. But that's, to answer your question, how that kind of works. Sloppily.
Thank you.
Anyone? Joe. Oh, wait, sorry, I've got to get the mic down. Wait, was there somebody back there? Maybe we can get the mic. I think I saw another hand, and we'll just kind of work it down, and then I'll get yours next as the mic comes down.
From someone who's more familiar with Jupyter and not so much with Zeppelin yet, I'm wondering about the execution engine that's really behind that. If I'm running a paragraph, can this client control program, is this going to run on my local server where I installed Zeppelin? Could I scale this out to Yarn to then have a Zeppelin server just doing the UI and a lot of doing the computation? How's that model work?
Yes. So when you are running, so let's kind of break it up, because there's different configurations we're talking about. So let's break it into different configurations. If you're running Zeppelin and Flink or whatever engine in local mode, your code is executed against like a little mini cluster. So everything will happen locally. It's a jar that handles all the interpreting and breaking things up and the paragraph controls. That's usually based, like on the Flink case, I think it's based off the I loop, which is the same thing that the Scala shell is based off of. It's just taking advantage of a lot of that functionality that's there. If you scale out to a cluster, then yes, for example, these jobs are all running against the cluster. And what it's doing though is, as I understand and the best I can tell, it runs the job. It checks the job locally to make sure it's syntactically correct. It'll check it for syntax errors. It's not going to submit a job that's never going to run. But assuming it's a runnable job, then it sends it off as like a command, just like you would at the Scala shell. And that's how it ships that off. Now, because of that, there are some kind of weird things with connecting and talking together. And I specifically mean that whatever version Zeppelin is built against has to be the same version that you're running in your cluster, or you get weird serialization errors. So if you're running Zeppelin 1.1.2 in the cluster, 1.0 on the cluster, but you're using this Zeppelin 1.1.2 on your local machine, it's just going to kick errors and it's not going to run. But it'll trick you. It'll run simple things like print line, hi mom. It won't run though as soon as you try to do something complex and then call like a collect statement on it. When you try to materialize a data set and then bring it back down, then it's going to kick an error because it tried to talk to the cluster. Things got weird at the job manager, and it said, hey, I'm out. And then as far as Yarn goes, the only thing stopping it from working on Yarn right now is if you ever look at like the Scala shellcode, there's a couple different little things it has to do to submit to a Yarn client. And while those are easily implementable, they haven't been implemented yet in Zeppelin, so we don't have Yarn support. But I would expect it very, very, very soon. Is my short answer there. But it works well on other Yarn-based applications.
So one thing is still not yet clear to me. So do you have a client control program which runs local to the Zeppelin web server?
I think yes, or maybe this guy shakes. I don't know enough about client control programs and what that means, to be entirely candid with you.
Okay, so then maybe we'll discuss this.
Yeah, there are jars locally running. It's controlling things.
I'll try to catch you after.
Okay, that sounds good. Sorry and thank you.
Mm-hmm.
Hello? Okay. Can you talk a little bit what's on the roadmap for Zeppelin, and maybe a little bit about how the community is organized and how it works?
I can. A big thing that everyone's excited and working about, well, the biggest thing that everyone's trying to work out right now is they recently bumped to Spark 2.0, and they are going through the growing pains of going from Scala 2.10 to Scala 2.11. Also, as you can imagine, this is a compilation of 20 different projects, all at different versions of Scala, at different versions of this and that. So I think trying to separate all that out and like get everyone kind of, until everyone runs on Scala 2, is kind of at least on the same version of Scala, and working like through those growing pains, that's really, I think, kind of the biggest focus at the moment. On the roadmap, though, Zeppelin is it's working at becoming more like having these exportable applications using Helium, which I haven't used a lot, but some people may be more familiar with. And the idea is, though, that, so for example, let me find a fun visualization. Jelly. All right. Let's say use case. You are a data scientist, and a salesperson asks you for some report, and you made the visualization, and they want to be able to share that with whoever they're talking to, but you don't want them to have access to the code because you just don't trust them that much. In case it happens, what you can do, because obviously you can take a screenshot, but now it doesn't do fun things, so that defeats the purpose. Link a paragraph. Now, as long as they're on the same subnets as you, they have no access to the code, but do have access to the output. And so that's a really, really cool feature in of itself that I kind of glossed over. Now, they're taking this further with this concept, with Helium, being able to take input and kind of building like almost like little mini apps around this idea of like, yeah, you can write some code over here, but then you can package it all up and ship it out as its own little application. And I think that's kind of a cool idea and a next logical step on this. But that, I think, is once again, that's once again, that's the direction I think the community's looking in, always building, incorporating new interpreters, doing new things. A lot of refactoring. A lot of the interpreters were committed by people from their projects, respectively. So kind of, straightening things out, getting things kind of more put in line, and features like that.
It's more a small question. I've been using Zeppelin also with Flink, and also especially the SQL part.
you haven't mentioned it, but I think the SQL part is one of the most powerful things of Zeppelin, especially because you can easily combine it with Spark or with. It also can make visualization and can open access to all kinds of data scientists. So, what is your opinion about it? Because as you're already telling us, there are lots of different interpreters, all kinds of things. But eventually, coming from a data engineering part, I see the SQL part taking over almost the whole Zeppelin use case. I see quite some big importance.
Yeah, so around the SQL, here's the thing on that though. The different SQLs that you get in the different interpreters, it's really the Hive interpreter that accepts SQL. So the onus is on the underlying engine to be able to support that. Now, Flink does have SQL support. Flink also has Python support, but we don't have a Python Flink interpreter. This is a matter of someone's got to go in and write it. But I agree. That would be, now that we're starting to see that SQL on streams, that would be amazing.
Yeah, because personally, I see the whole resource pool. I think it's a hack. It works.
Yeah.
But I think it would be better if it's more intuitively connected all together.
I agree. Yeah, it was. I think you're 100% right on that. And yeah, it's a good comment. Oh.
Okay, thank you. Just a little follow-up on that. The resource pool concept, if you're not running the mini cluster, but if you're running on the real cluster, can you still use it?
Absolutely. Yep.
Because I saw some things, like I also tried the automatic dependencies things, where you can add dependencies to the interpreter.
And it doesn't work well on the cluster?
And it works, I think it only works on then it compiles, your code compiles, but it doesn't run.
Yeah, so I did a little hand waving on this, and to be entirely candid then, the dependency uploader of Zeppelin doesn't do a great job of making sure that the jars end up in the cluster. So the hack around that, for the time being, is if you've got a jar that you know you're going to be using, just download that jar into your lib folder and the cluster. I had to do that too. Thanks for calling me out. But yes, it's something you need. It needs to be done.
Okay,
and
but the resource pool is actually, if it works distributed, so you can
because the way
it from
because the way the resource pool, and I'm sorry, I know we've got to shut this down, but the way the resource pool is working is those local interpreters, they're sharing it's in the local Zeppelin memory. So really, you can use a resource pool just from Scala. If you just had a Scala interpreter that had no engine behind it.
But it's working on local memory, so that means if your job really runs on a job manager.
Oh, you shouldn't handle like a data set off to try to hand that off to Spark. No, you can't. It's for small things like like lists or strings. Yeah. I'd say anything, if it's too big for an Excel file, don't try firing it across the resource pool. That's the wrong way.
Okay, thank you.
Yep. Okay, I guess we will close it out. If there's any more questions, please hit me up afterwards. And thank you very much for coming out. I know there's a lot of good talks, and I appreciate you guys coming to mine.